Good morning students, it's me Anurag Agrahari. Welcome you to the video tutorial of chapter 1 number system. Dear students, I hope you are following all the guidelines to remain safe from this pandemic COVID-19. Dear students, after learning of this chapter, you will be able to know about various number systems used by the human beings and electronic devices. After completion of this chapter, you will be able to do binary calculations and you will be able to understand how these binary calculations are performed inside an electronic device. So let's start the learning of the chapter 1, that is number system. Dear students, in early days the people used fingers, pebbles or different notations for their counting purpose. But these ways are not adequate for big countings and calculations. Later on, the mathematicians developed a way to count and calculate on numbers that is known as the number system. A number system is actually a set of values used to represent different quantities such as number of students in a class, marks obtained by a student, your roll number in the class, your age, your phone number, your marks obtained in any particular subject, your report card, everything. Wherever you find a number, that is due to a number system. The number systems are different in human beings and in electronic devices. The human beings are using the number system is known as decimal number system. A decimal number system is used by the human beings and it is having total 10 digits, that is from 0 to 9, 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. This number system is used by the human beings because in this number system there are 10 notations, so that is why it is known as decimal number system. The second number system, which is binary number system, is used by the electronic machines like calculators or computers. In this number system we have only two notations, that is 0 and 1. By using these two digits only, it can form any number of the world. Because in this number system only two digits are used, that is 0 and 1, that is why it is known as binary number system. The next number system, octal number system, is again used by the electronic machines for quite bigger calculations than the binary numbers. In this number system we have total 8 notations, that is from 0 to 7. 0, 1, 2, 3, 4, 5, 6 and 7. Because of total 8 notations, this number system is known as octal number system. The next and the last number system is the hexadecimal number system. Hexa means 6 and decimal means 10. So total of 6 plus 10 makes 16, which is known as hexadecimal. In this number system we have total 16 notations, that is from 0 to 9 all the digits, and after then from A to F alphabetic letters, where A represents the value 10, B represents the value 11, C as 12, D 13, E 14 and F for 15. So there are 4 types of number systems included in this chapter, where the one number system, that is the decimal number system, which is used by the human beings for their counting and calculation purposes, and other 3 number systems, that are the binary, octal and hexadecimal number system are used by the electronic devices, for example, computers. So let us take a quick view of different types of number system. You are watching a chart where in the first column there is the introduction of the number system. Second column is of base or also known as radix. The third column is for the representation of all the digits used by that particular number system, and the next column is an example for that particular number system. So let us go to the first point, that is the binary number system. In binary number system we have two digits as for use, that is 0 and 1. That is why its base is 2. Now the question is, what is a base? So you can see here the total number of digits used in a number system is called its base or radix. As you know, in octal number system we can use total 8 digits, that is why its base is 8. In hexadecimal number system we have 16 notations, that is why its base is 16. In the same way, the decimal number system has total 10 digits, that is why its base is 10. So it's very important to mention the base along with the number, because it specifies that which type of number system we are using or we are watching in front of us. So as example of binary number system, you can see the example. The number is having only two digits, that is 1 and 0, and its base is 2. So it represents that the particular number is a binary number system. The octal number system is represented by the radix 8. The decimal number system is represented by the radix or base 10. In the same way, the hexadecimal number system is represented by the base 16. So I hope you have understood all types of number systems and their bases. Let's know about how one number system can be converted into another number system. Here in this topic we are going to understand how the decimal number system, which is used by the human beings, can be converted into the binary number system, which is used by the machines. This conversion is important to know because what is happening actually inside the computer system we don't know. We just give our problems, for example 20 plus 20 is equals to, and as soon as we press the equals to symbol we get the result 40. But how this happens, we will understand it after knowing the conversion process. Students, when we give any problem in the decimal representation to the computers, first of all, those decimal values are converted into binary. After conversion into binary, they are added together or calculated together using the binary calculation rules, and after then whatever the result is obtained, that is also in binary, because when you calculate on binary values you get the result in binary. After then the central processing unit converts that binary result into again the decimal format so that we can understand it. So here two types of conversions are taking place, that is first from decimal to binary and second from binary to decimal. So let us understand how a decimal value can be converted into binary and again from binary to decimal. Conversion of decimal number into binary number. So here the first example we are going to observe, that is to convert a value 28 which is in decimals. We are going to convert this decimal value 28 into binary. So how to do it? Let's see. To convert a decimal number into binary, we used to divide it by 2, and during the division we will hold the remainders at one place. See how? So first of all, let us divide 28 with 2. We will get 14 and the remainder 0. So write the remainder at a side. After then, continue the division process till the dividend becomes 0. So now again divide 14 with 2. We'll have the quotient 7 and the remainder 0. Divide 7 again by 2. So 2, 3 is 6, and this time we will have the remainder 1. Again divide 3 by 2. So 2, 1s are 2, and this time we will have the remainder 1. Now because this 1 cannot be divided by 2, so but deliberately we will divide it by 2 with the help of a 0, like this. So 2 zeros are 0, and this time again we will have the remainder 1. Now you can see some sort of remainders are stored over here. The first remainder which we have obtained in the starting of the division process is known as LSD, that is the least significant digit, and the last obtained remainder, which is here, it is known as MSD. The full form is most significant digit. After doing the division process, we will check out the LSD and MSD, and we'll write all the remainders from MSD to LSD, that is from bottom to top. Like you can see 1 1 1 1 0 0, that is in order to bottom to up. So this is the way we have to write the remainders to obtain the answer. So here the binary of 28 is 11100, and this remainder is not visible properly, the base is not visible properly, so I'm making it for you, that is 2. So don't forget to place the base along with your answers. So was this process easy to understand? Let us have more examples. But before the next example, let us go through the steps to convert a decimal into binary. So the first step is divide the given decimal number by 2, write down the remainder and divide the quotient again by 2. Repeat the step 2 until the quotient becomes 0. Write the remainders obtained in each step in the reverse order to form the binary equivalent of the given decimal number, that is, placing the least significant digit at the top and most significant digit at the bottom. Now again have a conversion of converting a value 75 of decimal into binary. So by using the same process, 75 is divided with 2, we have the quotient 37 and the remainder 1. Again 37 is divided by 2, we have 18 and the remainder 1. The division process continues till we have the quotient as 0. Now from bottom to top means from MSD to LSD, write down all the remainders, that is 1 1 0 0 1 0 1 1. So 1 0 0 1 0 1 1. So this is the answer. Let us know how to convert a binary number into decimal number. I hope you have understood how to convert a decimal into binary. The process is very easy. Only we have to divide the numbers by 2 till we have got the quotient as 0. After then write all the remainders from MSD to LSD order and place the base as 2. In the same way, students, if you want to convert a decimal number into octal, then you have to divide that particular number by 8. And in the same way, if you have to convert a decimal number into hexadecimal, the division have a slight change. Now you have to divide the values with 16. Okay, let's know the conversion process of a binary number into decimal number. So suppose we have to convert 1011 into decimal number. So how to do it? The process is very easy. Just take a careful look onto your screen. The first step, write down all the binary values like this, 1011. After then, start placing powers onto them starting from 0 and from the right hand side from here. So on the first digit place the power 0. In the same continuation on the second digit place the power 1. The next digit just increase the power values. So you can see on all the digits now a power is placed, but the power is placed from the right hand side starting from 0. After then, take the first digit and multiply it with 2 and keep the same power which is on the first digit, that is 0, on the 2. So now the equation will be like the digit 1 into 2 to the power 0. Solve it. You know well, any number which is having the power 0 is equals to 1. So 2 to the power 0 is equals to 1 into 1 will give a 1. Now do this process for the next digit. Take the next digit, that is 1, multiply it with 2 and put the same power on 2 that is on that particular digit, that is 1. So 1 into 2 to the power 1, where 2 to the power 1 is equals to 2 and 2 into 1 will give a 2. Do this for the rest of the digits. Now take the next digit, that is 0. So 0 into 2 to the power 2. 2 to the power 2 because the 0 is having the power as 2. So 2 to the power 2 will give a 4 and 4 into 0 will give a 0. Take the last digit, that is 1, multiply it with 2 again and put the same power on 2 which is on this particular digit, that is 1. So 1 into 2 to the power 3. 2 to the power 3 will give a 8 and 8 into 1 will give 8. So after doing all this, we have to add all these obtained results. So when we will add it, we will get 11. So this is the answer. We will write like 1011 of a decimal is equals to 11 of 1011 of binary is equals to 11 in decimal. So to convert a binary number into decimal number, the steps we have to follow is, the first step, put powers to all the digits starting from 0, 1, 2. Do powering from the right to left digit. So whatever digit is at your right, start powering from them, and power should be start from 0. The second step is multiply each binary digit with 2 to the raised positional power. At last, calculate sum of all the products to get the decimal number. Let's have one more example. Convert 111 of a binary into decimal equivalent. So what we will do, we will first write all the digits, that is 1, 1, 1, and then we will place the powers, that is 0, 1, 2 from the right hand side. After then, we will take the first digit and multiply it with 2 with the raised power. We will do this same activity for all the digits. At last, we will add them together. The obtained result is the decimal equivalent of the given binary value. So thus 111 of binary is equals to 7 of decimals. Students, I hope you have understood both the process very easily, the process of converting a decimal into binary and again a binary into decimal. So in this part, I'll cover this much only, the conversion process. In the next part, I will tell you how to calculate the binary values, like the addition of binary values, the multiplication of binary values, subtraction and division of binary values. So till then, stay home, stay safe, and don't forget to follow the COVID guidelines. Thank you, students.